Good day, my name is Harunan Munirajan, DF220216. I'm here to present about the introduction of this project. The equatorial climate of Malaysia, a nation on the equator, is described as being hot and muggy all year round. There will be 2 monsoon winds season in Malaysia that falls, rain, snow, drizzle, glaze, sleet or hail from the cloud to the Earth's surface is referred to as rainfall. Initial effects of the rainfall episodes includes the growth of plants, evaporation and soil penetration. The most damaging natural calamity to occur the Earth. Flooding is brought on by build-up of water in one particular location. High intensity and moderate intensity rains are mostly associated with flooding. Next is problem statement. Flood catastrophes appear to have more in common in recent years. Higher runoff rates brought on by development and the reduction of flood storage are the main contribution to the floods. The daily rainfall measurement from Liang, Batu, Kampung Ola, Sepam and Pancho are the 3 rainfall gauges stations situated in Muar district, Johor. Using rainfall and water level data, this study attempts to estimate the annual mean precipitation of the study region, the peak flow, the discharge of river at higher water level and the unit hydrograph. Next is the objective of this project. The first objective is to calculate the mean aerial precipitation of the research area. Next, to determine the peak flow of the proposed catchment location and discharge at the maximum water level. Third is to identify and map the research area units.
Okay, methodology. For calculate the catchment area, we use a geographic information system program called Google Earth Pro. Google Earth Pro enable the visualization, evaluation, overlay and generation of geographical data. Okay, for water level and rainfall, we use a public info banjir. Public info banjir is one of the Department of Irrigation and Drainage. Okay, geographical characteristic. Okay, we use 2 rainfall station to obtain the catchment boundary because there is an issue of another rainfall. The rainfall station being located too far and disturbed in a close-up boundary. Okay, we can see here catchment boundary, terrain profile and gradient profile. Okay, this data we collect on Google Earth Pro. Okay, we can see also a cross section of Sungai Muar. This also we collect in a Google Earth Pro.
Okay, so for mean area rainfall, we have 3 methods to use. For our group, we have arithmetic mean method, Tizen polygon, and for the last one is isohyter. Okay, so for arithmetic mean method, what is arithmetic mean method? Arithmetic mean method is a technique calculates the real precipitation using arithmetic mean of all the points from data given. So we can see the formula, that is sum of the data divided by total of data. So for our group, we have arithmetic mean method for value is 46 mm. So for Tizen polygon, what is Tizen polygon? Tizen polygon is function to use for determine the average rainfall on catchment area. So as you can see, we gave a catchment area here. Okay, so for our Pancho station and our Kampung Olak Sepam station, and for find the Tizen polygon, we use this formula, that is sum of polygon area for each station times by precipitation over by sum of total polygon area. So we can see from the table, we get an area, we get a precipitation, and we get the area times by precipitation. So we can get our Tizen polygon is 41.24 mm. Alright, so before we go through the isohyter method, I want to remind that is why our group just use 2 stations, which is Kampung Alak Sepam and Pancho Station to get a mean area rainfall. It is about for the third station is so far away, so I just consider to take a 2 station only. Okay, so for the isolated method, it's used for estimate the mean precipitation across an area by drawing lines of equal precipitation, or we can call it as give for the area catchment area. We just take a by part we say it by part. Okay, so for the first we must search our isolated interval by part, and we give a by part 0 to 15, 15 to 30, 30 to 45, 45 to 60, and 60 to 75. And then we must get the average precipitation at that point, and then we get the area for the point that we give the part by part, and we get the value of area times to average precipitation. Okay, so as you can see, I get my isolated value. Our isolated value is 41.18 millimeter. So this is our peak flow and discharge. Peak flow for rational method, and discharge for cross-section method. And we can see our value this for peak flow is 58.31, and discharge is 5091.56 meters square per second. Meter cube per second. Thank you.
Assalamualaikum and hi, my name is Muhammad Arif Daniel Berizwan. My metric number is DF220090. I'm going to explain about discussion. Using the mathematical technique, the average annual precipitation for these two locations is 46 mm. The average amount of precipitation for these two locations according to the Thiessen Polygen technique is 41.24 mm. The final result of the isolated approach is an average precipitation value of 41.18 mm. We employ two techniques to ascertain the peak flow of a catchment: the rational approach and the cross-sectional area of the river. The cross-section of the river is 5091.6 meter cube per second, and the peak flow of the rational technique according to this approach is 58.31 meter cube per second. The results vary because our choice of runoff coefficient and catchment area delineation has a significant impact on the rational method's correctness. Because we were unable to obtain the precise amount, we utilized the Google Earth tool to approximate the necessary information. For the last part is conclusion. Through finishing the study, we gain knowledge on how to distinguish and control the link between precipitation and runoff. Additionally, we can demonstrate that runoff rise together with precipitation up until the peak of release. We note the release and the timing for each catchment range using rain as a medium. Utilizing the hydrological framework was necessary for controlling the water level. Common surface determinant, soil invasion traits, and seepage design are further important runoff preparation factors that are shaped by common streamways.